Okay, so the first part of this topic has been about ratios. Hands up who can tell me something about ratios. Riley, is that a hand up? No. No one knows anything about ratios. Yes, Ethan?
Put the numbers next to each other.
Yes, good. And the order is important, isn't it? Because if it says cats to dogs, you need cats first and then dogs second. Anton, what do you know about ratios?
When it comes to ratios, the best ratio is to scale.
Oh, we did scales with ratios. Enlarging things by a scale factor, yes. Anything else? Cash, what do you know about ratios?
You can simplify them.
Yes, you simplify them by dividing by the highest common factor. Very good. Anything else? Highest numbers.
It involves numbers.
It does involve numbers. There's something else in particular that I was looking for, Layla? The ratios, all the ratios that we see when they're simplified don't have units. Okay, sometimes we have to make the units the same and then we simplify them down. Okay, so ratios typically should not have any units. Okay, so summary, ratios have the two dots, we make the units the same and we simplify them so that there's no units in our answer. When we move on to rates now, different, slightly different. A rate is used to compare two different quantities. Now, I'm not talking about like meters and kilometers because they're both distances, right? I'm talking about two completely different types of units, like meters and seconds, like to do a speed, meters per second, right? So rates are completely two different types of units. You'll often see a little like backslash, and that means per. So when you do the kilometres per hour or the metres per second, use that slash instead of writing the word per. You must always include units in your answer. So that's like the opposite of ratios. Ratios don't have units, but rates must have them. And they will look like this, kilometres per hour or cents per litre or metres per second. The two different types of quantities that we're comparing are in those units. A rate is considered to be simplified if it is per 1 unit. For example, 20 kilometres in 2 hours is not simplified because it's for 2 hours, not 1. But if we divided the 20 by 2, it would be 20 kilometres per 1 hour or 20 kilometres per hour, and that is a simplified rate. Sometimes you'll see some questions that say average rate. Now that would be used for something like when you're driving in the car and you're not always doing the exact same speed. You might be on the freeway, you're doing 110 there, but then you go through a little town and the speed drops down to 80 or then 60. But over your whole trip, maybe you've done 300 kilometres and you did it in, I won't say 3 hours because that'd be a bit fast, wouldn't it? But it'd be easy calculation. If you did it in 3 hours, that means over that whole trip, you are averaging 100 kilometres per hour. But you're obviously having some parts faster and some parts lower. It's an average. Okay, and there's an example here about a book. You're reading a book, there's 600 pages in the book and it takes you 8 days to read it. Some days you may read more pages, some days you may read less. But on average, if you divide those numbers, 60 divided by 8 is 75, so that is a 75 pages per day average that you would be reading to finish that book. Okay, anyway, so the first question here, it asks us to find out what quantities are being compared in the following rates. What units are we having there? I'm not actually asking you to find a number. We want to look at the units that are there and state what type of measurement that is. So it says dollars per kilometres. Dollars is a unit that we use in money, and kilometres is something that we use to measure our distance. Good. So the two different types of quantities we're comparing there is money and distance. How much money to go, how far a distance, right? And the next one, we have millimetres cubed per hour. What do we measure in millimetres cubed? Yes, Cash?
Distance?
No. Sorry, no. Millimetres cubed. Yes, Riley?
Area?
Close. You're on the right track, Si. Yes. When it's cubed, it is a volume. So that is a volume, and hours is a type of time. So we're comparing volume and time. Part C, cents per milliliter. Cents, again, is money. We seem to have a lot of money in here. And milliliter. What do we, we measure water with milliliters or capacity. Really good. When we measure liquids, we call them capacities. And D, kilograms per year. Kilograms is what? A weight. We tend to call it a mass, though. You can call it a weight. I'd accept that. And year is another type of time. All right, good. Question 2. Let's get down to the real business here. Express each of the following as a rate in simplest form. Whenever you're trying to simplify a rate, I would like you to always write your question as a fraction first because it makes it easier. So 240 kilometres, we're going to put that on the top, and then it says in 5 hours, so I'm going to put a 5h for hours on the bottom. Now you usually can do that, just the first one over the second one. Please always put the kilometres and the hours on there because we know we need those units for the answer, and it actually helps you see what that should be. So from there, you will now divide the numbers. So 240 divided by 5 is 48. And then to do the units, it's the top one per second one, kilometres per hour. Some questions may specify that they want kilometres per hour, or if they specify that they wanted hours per kilometre, which is a bit weird. But if they did say that, it would just mean that you put the other one on top. You put whichever one's first in the thing, you put that first in your fraction. Let's try the next one. $84 in 6 hours. So make the fraction. $84 and 6 hours. Divide the numbers. 84 divided by 6 is 14. Money, dollars, is the weird one. All the other ones, we put our kilometres per hour here at the end, but dollars goes out the front of the number, doesn't it? We never go like $14 like that. That's a bit weird. Dollars always goes here. $14, and then we'll go per hour. But it only happens for dollars. All the other ones, they both go at the end. C, we're playing cricket now, and we are doing 68 runs in 8 overs. So 68 runs is going to go on the top, and 8 overs, 68 divided by 8 is 8.5 runs is on the top per overs, which is on the bottom. That's pretty good, right? 8.5 runs per over. Is that pretty high? I don't know. Don't really play cricket either, but anyway. D, we have 36 apples for $5.40, but wait, look at the bracket. The bracket says that we want that as cents per apple. So if it's specified that, first of all, it means I'm going to have to put that $5.40 in cents. What's that? How many cents are in $1? 100. So if you times that number by 100, it's 540 cents. Also, because it says cents per dollar, even though the cents is the second number, that's the one that I have to put on top. So I want 540 cents on the top and apples on the bottom. 540 divided by 36 is 15 cents per apple, which seems ridiculously cheap, but anyway. But that makes sense to write that way, doesn't it? It's like at least 50 cents an apple now, more like 60 or 70 probably. Anyway, question 3. Bob can type 296 words in 4 minutes. What is his rate in words per minute? So words has to be on top. and minutes has to be on the bottom. 296 divided by 4 is 74 words per minute. You're saying that slow. Can you type faster than that?
100%. Yeah, for sure.
Well, I'd like to see that. With 100% accuracy, I hope.
Oh, well, no.
Oh. All right. Question 4. Next page. Oh, sorry. Let me slow down. All right, we're set. Question 4. So these last couple of questions, I think there's only 2 more. Yep. Are a bit more of an applications of how we can use our rates. So the first one, number 4, says Tom was 120 centimetres tall when he turned 10 years old. He was 185 centimetres tall when he turned 20 years old. Find Tom's average rate of growth per year between ages 10 and 20 years. So first of all, we're going to need, we only ever compare 2 different quantities, right? The 2 things that we're comparing here is how much he has grown, or his growth, and the other thing that we need is how much time has passed when that has happened. So his growth, he started out at 120 centimetres, and I'll highlight them for you. So he started at 120 and was 185 at the end. So if I subtract those 2, 185, always start with the bigger number, 185 minus 120. Actually, I shouldn't say always start with the bigger number, always start with the second number. That is a 65 centimetre growth in that time.
You have to do the working,
Yeah? Okay. Now, time. We started measuring when he was 10 years old, and the second measurement was at 20 years old. So that's a pretty easy calculation, I hope. That's 20 take away 10. That is 10 years. I probably should write years on there. 10 years that it took him to grow that 65 centimetres. So remember the average. We did talk about an average growth rate. He might not have grown the same amount every year, but we want to average it over those 10 years. So his growth rate is going to be the 65 centimetres that he grew over the 10 years. Yes. Now we divide the numbers. 65 divided by 10 is 6.5 centimetres per year. Okay, so probably, if we thought about it, being that he's 10 years old, he probably would have grown majority of that in, the first, 13, 14, 15. By the time he probably hit 17, 18, 19, 20, he probably wasn't growing much anymore. But it's the average over that time that he grew 6.5 per year. Yeah, all right. One last question. Martine grew at an average rate of 6 centimetres per year for the first 18 years of her life. If Martine was 50 centimetres long when she was born, how tall was Martine when she turned 18? Okay, so this is kind of reversing it a little bit. I know the average growth rate and I want to find out how tall she is when she's 18 years old. So let's find out how much she has grown, her growth. If she grows by 6 centimetres a year on average, and she does that for 18 years, I want to do 6 times 18, which means that her growth is 108 centimetres. But that is not how tall she is when she's 18. Her total height is going to be, she started when she was born. She didn't start at 0. She started at 50 centimetres and she has now grown another 108. So she's now going to be 158 centimetres tall.
That's actually not that.
That's not that tall. Shorter than me.
I am.
I know I'm short. Anyway, I am short.
That is quite